So this is going to be a video on section 1.6 where we're going to be dealing with rational equations. So notice here, first of all, that a rational equation is going to be an equation that has a rational expression. That's just code for it's got fractions in it. This next part here, this is important. To solve a rational equation, you want to multiply on both sides of the equation by the common denominator. And what this is going to do for you is it's going to eliminate your fractions. And then what you'll do is just solve the resulting equation. Because the rational expression is not defined when the denominator equals 0, you guys know that you cannot have a denominator of 0. So any possible solutions for which the denominator equals 0 have to be thrown out. They have to be excluded. So basically, and I'll show you this, if you've got a solution, an answer that makes the original denominator equal to 0, you have to throw it out. So let's jump right on into part A here of this first example. And so the very first thing you want to do, if we're following the directions, we want to multiply by the common denominator. So the way I like to do this is simply take the first denominator, that will be part of my denominator, so that's a 2, and I'm going to multiply by the next piece of the denominator as long as it's not a repeat of what I've already used. And so I'm going to multiply by that quantity x plus 1. Now this is over 1. Since I'm multiplying on both sides, it's completely legal. And so I'm going to distribute this to each term. So when I distribute to the first term, notice that the 2 on top and the 2 on bottom, these guys are going to cancel each other out so that all that's left over is going to be a 2x minus 3 and an x plus 1. The 2x minus 3 coming from here and the x plus 1 is coming from here. When I multiply by the second term, notice that the x plus 1s are going to be the ones that are canceling each other out. So the only thing that'll be left over is going to be a 5x and a 2. And then lastly, when I multiply by the final term over on the right-hand side, nothing cancels out. So that means I'm left with an x, I'm left with a 2, I'm left with an x plus 1. So now let's go ahead and clean this up. And so when you FOIL the first term, you're going to get 2x squared minus x minus 3. When you multiply the second term, you'll get 10x. On the right-hand side, cleaning that up, you'll get 2x squared plus 2x. Now let's go ahead and combine our like terms. So that'll be 7x minus 3 equals 0. Solve, and you get an x is equal to 3/7. Now make sure that you always check your solutions. If I take this solution and I plug it back into the original equation, notice that 3/7 is not going to make the denominator here equal to 0. It won't make the denominator here equal to 0. And this denominator is just a 1. It won't make that one equal to 0. So it's a good solution. We're allowed to keep it. All right, so now let's go ahead and move on to the next example, doing the exact same thing over again. First thing, let's get a common denominator. So let's use all of the first denominator, which is an x minus 5. The second denominator is just a 1. I don't need to multiply by a 1. And the third denominator is x plus 5. Well, I've already used this one, so I'm not going to use it a second time. So the only common denominator here is x minus 5. We're going to take this denominator and we're going to pass it to all 3 terms in my equation. So when I take the x minus 5 and pass it to the first term, it's going to go ahead and cancel with the denominator. The only thing I'm going to be left with is an x. When I pass it to the second term, there is no denominator, so I have to keep the 5 and I have to keep the x minus 5. And then when I pass it to the right side, the x minus 5s are going to cancel. The only thing that's going to be left over is a 5. So let's go ahead and clean everything up by distribution. And then let's combine like terms and solve our equation. Now let's take our solution here and let's take it and put it or substitute it into the original equation. Unfortunately, this solution causes a 0 on bottom. So that means I have to throw this solution out. It's a bad solution because it makes the denominator equal to 0. I have no solutions for this particular equation. Let's go to example number 2. example number 2. Once again, I need to multiply by the common denominator. Now, on this one, before I multiply by the common denominator, notice that you have a denominator that can be factored. Let's go ahead and factor this denominator first by pulling out the GCF. It's the same thing as x times the quantity x minus 3. So now let's find our common denominator. We'll use all of the first denominator, and then we're going to use all of the second denominator. So let's write those two things down. Notice when I go to my third denominator, I've already used these two pieces, so I'm not going to use them again. Now let's go ahead and take our common denominator and distribute to all three terms. First thing is that my x minus 3's are going to cancel. So that's going to leave me with an x times an x minus 5. The only things that are left over are going to be the x minus 5 and the x, because the x minus 3's canceled each other. And then when I take it to the second term, notice that the x and the x will cancel each other. This is only going to leave a positive 1 and an x minus 3. On the right-hand side, the x and the x minus 3 are going to cancel. The only thing that's going to be left over is a negative 7. Let's go ahead and clean up the left side by distribution. The right side is just a copy. And then we'll combine like terms. Now we have a quadratic. I personally would rather use factoring on this particular quadratic as I solve. And so I factor my trinomial. The only solution here is an x equals 2. When I go and I check my solutions, if I plug an an x equals 2 into my original equation, nothing makes a 0 on bottom, so I'm allowed to keep this as a solution. Let's go ahead over to part B and do the same thing. So the very first thing that we want to do is we want to factor that denominator. It's a difference of two perfect squares, so that's going to be x minus 5, x plus 5. And then after we factor, let's go ahead and, I'm sorry about that. I'm getting ahead of myself. Let's get our common denominator. So we'll use our first denominator and our second denominator. But you'll notice that when we get to our third denominator, we've already used both of those pieces, so I'm not going to use them a second time. And now I'm ready to distribute that common denominator to all three terms. For the first term, x plus 5's cancel. The only thing that's going to be left over is going to be an x and an x minus 5. When you distribute to the second term, the only thing that's going to be left over is a positive 5 and an x minus 5. And then when you distribute to the third term, everything cancels, leaving you only with a 50. Let's go ahead and distribute. And then we'll combine our like terms. When we combine like terms, notice that I have a difference of two perfect squares. So when I factor this, this is going to be an x plus 5, x minus 5. And when I solve, I'll have an x equals a positive or a negative 5. When I go and check my solution, notice that neither of these solutions is going to be a good solution, so I have to throw out both solutions. So in this particular case, I have no solutions that will work. And then we'll go down to example number 9. Okay, so there's a good bit that we cut out in this particular section. So example number 9 is the only other one that we're going to do here, and we're solving the equation as though it is quadratic. Now, I know this is a fourth degree equation, but it looks a whole lot like something that we've done before, 18x squared minus 29x plus 3 equals 0. So we're just going to pretend that it's a quadratic, but we're going to solve it as though it is actually a fourth degree. So the first thing that we'll do is we'll factor, just like we would have if this were a true quadratic. And so notice we've got a 9x squared times a 2x squared. These are our firsts, giving me that 18x to the fourth. And then for our lasts, we have a negative 1 and a negative 3 being multiplied together to give me my positive 3. So then I'll set up my mini equations. This is going to be a 9x squared minus 1 equals 0, or a 2x squared minus 3 equals 0. And then let's go ahead and start solving this first mini equation. And so we'll add 1 to both sides. We'll divide by 9 on both sides. And then we need to get rid of the square. So we're going to square root both sides. Don't forget your pos neg. When I take the square root of the top and of the bottom, that's going to be a 1/3. Square root of 1 is 1. Square root of 9 is 3. Now let's go over to our second mini equation and we'll solve that one. So we'll have 2x squared equals 3. Divide on both sides by 2. Take the square root of both sides. Don't forget your plus minus. Zoom in a little bit. Now remember that you're not allowed to have a denominator that has a root in it. So let's multiply top and bottom by the square root of 2 so we can get rid of our roots on bottom. On top, square root of 3 times the square root of 2 is going to be the square root of 6. And on bottom, square root of 2 squared is going to be just a plain old 2. Don't forget your plus minus. And so this one actually has 4 solutions, and that's not a surprise. Remember, we keep talking about my highest power will tell me how many solutions I have. So there's a plus or a minus 1/3, and there's a plus or a minus root 6/2 for a total of 4 solutions.